The ground didn't explode once and go quiet. It exploded, and then it kept failing for days afterward, in exactly the way scientists have been warning about for years. Not a bigger blast. Something slower and honestly more unsettling. A patch of solid earth that people had walked across without a second thought simply gave up on holding its own weight, sank into boiling water below, and then, on its own schedule, started spouting into the air like it had a mind of its own. By the time we're done here, you'll understand exactly why researchers have spent years dreading this specific sequence, more than a big dramatic bang, and why watching it finally happen in the one spot on Earth wired to record it might be the closest science has ever come to seeing the warning signs everyone said didn't exist. Here's the thing scientists have quietly worried about for a long time. Not the explosion itself. The explosion is the easy part to understand. Water gets superheated underground, a mineral seal traps it, pressure builds, the seal fails, steam expands violently, ground goes flying. That's a known process. What actually keeps hydrothermal researchers up at night is the part that comes after the bang, when the ground doesn't just crater and settle, it destabilizes, it keeps collapsing, reorganizing, and opening new pathways for days, as if the initial blast only cracked the lid instead of relieving the whole system. And that's the scenario people in this field have described as the genuinely hazardous version of a hydrothermal event, because it means the danger doesn't end when the noise stops. It means the ground itself becomes untrustworthy for an extended stretch of time in a place where visitors are usually already walking again by the following afternoon. And that is precisely what happened this year at Biscuit Basin in Yellowstone National Park, in a location scientists had already flagged as one to watch closely. Rewind for a second to set the stage, because the history here matters enormously. On July 23, 2024, a thermal feature called Black Diamond Pool erupted violently, hurling mud, rock, and scalding water 400 to 600 feet into the sky, tearing apart the boardwalk where tourists had been standing only moments before. Nobody was hurt, which by most accounts of people who study this stuff is close to a miracle. The park closed the basin immediately, and it has stayed closed ever since, because of the ground. They're never fully calmed down. Black Diamond Pool kept erupting on a smaller scale through 2025, month after month, a persistent reminder that whatever weakened the rock down there hadn't healed itself. Then came June 13th, 2026. Just after 5 in the morning, monitoring equipment inside Biscuit Basin picked up a sharp burst of seismic energy paired with infrasound, the low-frequency pressure signature of something forcing its way through rock. It was coming from the direction of Black Diamond Pool again, and the obvious assumption was that the same infamous feature had blown a second time. But the temperature sensor, sitting directly inside that pool, barely twitched. Whatever had exploded, it wasn't the pool everyone had their eyes on. The real story came from a camera installed at the site less than a year earlier, in May of 2025. At 5:09 and 50 seconds that morning, it caught a dark plume of steam jetting upward from a stretch of ground just north of Black Diamond Pool that had never done anything remarkable in recorded history. Flat, unremarkable. No name, no warning sign, nothing. The Earth simply opened there instead. When geologists reached the site, they found not one new hole, but 3 freshly punched vents releasing large volumes of hydrothermal water downhill into the Firehole River. By the time scientists arrived, most had already gone quiet, but the northernmost vent was still actively feeding the river, attached to a jagged fracture running north-northwest, roughly 18.5 meters long. About 61 feet, gaping as wide as 1.5 meters, close to 5 feet across in places. The water measured around 90 degrees Celsius, close to the boiling point at that elevation of 93 degrees. This was near boiling water, forced violently up through rock that had been solid the day before. Here's the part worth sitting with, though, because on its own, this was not an especially dramatic event. The rocks thrown by the blast only scattered a few meters, telling scientists the explosive force itself was modest, nowhere close to the 2024 event, that scattered debris across roughly a square kilometer. Judged purely by the size of the bang, this was a minor hydrothermal explosion, the kind that happens somewhere in Yellowstone roughly once a year. Downstream, though, the Firehole River turned a pale, milky gray for several miles, visible proof that the shallow plumbing system underneath the basin had just flushed a huge volume of sediment-choked water out of itself in a very short window, and then the ground kept going. This is the sequence that has no real precedent, and it has nothing to do with how big that opening blast was. In the days following June 13th, scientists watched something new form that simply hadn't existed when they first walked the site. A pool of water appeared near the middle group of vents, vigorously boiling, gray and thick with sediment. Most new features that suddenly appear at Yellowstone are explosion craters, punched outward with a visible ring of ejected debris surrounding them. This pool had none of that. According to the United States Geological Survey, it didn't form through an explosion at all. It formed through collapse. The ground itself caved inward, sinking into the hot, pressurized zone beneath it, and the resulting depression slowly filled with boiling water. Scientists determined the pool must have formed sometime between the afternoon of June 14th and the morning of June 16th, meaning ground the geology team had personally walked across only 2 days earlier had, without warning, become an actively boiling hole in the earth. Picture that for a second. A location scientists had physically stood on, inspected, photographed, quietly gave way beneath its own weight days later, with no explosion to announce it, no debris field, no obvious signal. Just a slow structural failure happening out of sight, underground, until the surface finally couldn't hold anymore. The measurements make it feel tangible. The new pool came in at roughly 6.5 meters by 5 1/3 meters, about 21 feet by 17 feet, filled with boiling water where solid ground had been, standing days earlier, and it didn't sit there passively. By June 18th, it had begun erupting entirely on its own, going through multi-minute episodes of spouting, throwing boiling water 20 to 30 feet into the air, roughly the height of a 2- or 3-story building in sustained bursts. There's something specifically unnerving about a feature that forms through collapse rather than explosion, and this is really the heart of why researchers have long treated this pattern as the more dangerous version of the hazard. An explosion is a single violent release. Frightening, certainly, but over in seconds, and you generally know it happened because the ground announces it loudly. A collapse is quieter and, in a strange way, far more revealing. It means the ground beneath the surface had been hollowed out or weakened enough that it could no longer bear its own weight, so it simply sank on its own schedule, sometimes days after whatever originally destabilized it. In the meantime, the surface can look completely intact. A person could walk directly across it without any indication anything was wrong, and then, quietly, it gives way. Lay out the full sequence, and this becomes the real anomaly of the entire event. An explosion on day 1, a fracture and 3 vents. Then, 2 to 3 days later, the ground collapses inward, giving birth to an entirely new boiling pool where there had been nothing before. Then, 5 days after that, the new pool starts spouting on its own with no external trigger. The hazard didn't end when the bang stopped. The system kept failing, kept shifting, kept opening new mouths in the earth for the better part of an entire week. Scientists were literally standing on ground that, days later, caved into near boiling water. That's the exact scenario researchers have warned about for years when discussing what makes hydrothermal hazards genuinely difficult to manage. Not the loud, obvious blast that people can see coming or run from. The slow, silent failure underneath ground that looks completely stable in places where millions of visitors walk every single summer. And this time, for the first time in recorded history, it happened close enough to dedicated instruments that scientists may actually have caught it happening in real time. The single most important number in this entire story is 100 meters, roughly 328 feet. That's the distance between the explosion and a monitoring station the Yellowstone Volcano Observatory had installed only the previous summer in 2025. According to the observatory, no hydrothermal explosion in recorded history has ever occurred this close to dedicated scientific instruments before. This is the tightest range anyone has ever had on an event like this as it actually unfolded. Contrast that with 2024. When the much larger explosion tore through Biscuit Basin that July, there was no dedicated hydrothermal monitoring station anywhere nearby. The broader instrument network barely registered it. One of the most dramatic hydrothermal blasts in the park's modern history happened, and scientists were left reconstructing it afterward from scattered debris, with very little real-time record of what actually occurred. This time, everything was reversed. A seismometer essentially next door, an infrasound sensor listening in continuously, a temperature probe sitting in the pool itself, a camera pointed directly at the ground. When the earth opened up on June 13th, every one of those instruments was running, all within a football field's distance of the blast, recording continuously. For the first time, scientists may have a high-resolution, close-range record of exactly how one of these explosions begins, the seismic signature in the seconds beforehand, the acoustic pulse, the thermal behavior, the entire visual sequence, frame by frame. That's why researchers involved describe the specific event as an unprecedented opportunity, in the driest and most literal sense of that phrase. Not because it was a big explosion. It wasn't. Because of what it might reveal about the moments leading up to failure in a hazard that has historically given almost no warning at all. The scientist in charge of the observatory has been candid about what they're actually looking for. Identifying a genuine precursor, some detectable signal in the minutes or hours before a hydrothermal explosion, would be a meaningful step toward protecting people in geothermal areas around the world. And he's been equally candid that such a precursor isn't known to exist yet, and that he isn't confident they'll find one this time either. But this was, in his words, a pretty good situation. because the instrumentation was in the right place at the right time with a large amount of data already collected, and nobody was ever threatened by the activity. Which brings us to the honest, uncomfortable part of this story, the part that actually deserves the word terrifying more than any lava-adjacent doom scenario ever floated online. There is a real possibility that when scientists finish combing through this data, they find nothing. No slow creep in temperature, no subtle shift in the infrasound signature, no flicker of tiny micro-earthquakes building beforehand. If the ground stayed completely silent right up until the moment it tore open, that confirms the darker version of this hazard that researchers have quietly worried about for years. It would mean these explosions, and the slow structural collapses that can follow them for days afterward, can strike from apparent calm with no detectable warning whatsoever in terrain where millions of people walk every single summer. That is the actual warning scientists have been circling around for a long time. Not that Yellowstone Supervolcano is stirring, but that the ground in these thermal basins can fail silently without a single instrument catching so much as a whisper beforehand, and then keep destabilizing itself for days after the initial event, right underneath feet that assume the danger had already passed. Let's be completely clear about what this is not, because the online reaction to anything unusual at Yellowstone follows an exhausting, predictable script. Every time this park does something even slightly out of the ordinary, the same wave of claims floods across social media within hours. The supervolcano is waking up. Officials are hiding an imminent continent-ending eruption. New vents and rising steam are somehow the final sign before the big one. The data flatly contradicts all of it. Yellowstone's volcano alert level has remained at normal throughout this entire sequence. The aviation color code has stayed green. In the month before this event, the entire park recorded only a small handful of minor earthquakes, none larger than magnitude 2.0, a tremor most people wouldn't even feel standing directly on top of it. There were no earthquake swarms, no significant ground deformation anywhere in the broader caldera system. Nothing suggesting magma is rising toward the surface. A hydrothermal explosion like this one is a shallow local steam event, driven by groundwater and pressure just a few feet underground, not by molten rock pushing upward from below. It is not a precursor to a caldera-scale eruption, and researchers who study the system for a living have said as much repeatedly and without hedging. But here's what the doom mongers consistently get backwards, and it's genuinely worth sitting with. There's a real hazard at Yellowstone. It's simply not the one people picture from disaster movies. The honest danger isn't a river of lava. It's a thin, sealed crust of superheated ground holding back near boiling water in places where tourists casually walk every summer, ground that can give way with little or no warning at all. In 2024, that exact dynamic destroyed a boardwalk full of people moments after they managed to run clear of it. The fear driving all the supervolcano panic online is real fear, aimed at entirely the wrong target. People worry about a magma chamber sitting miles underground when the thing that could actually hurt someone is a few feet beneath their own boots. To keep this properly in proportion, it helps to know how often the Earth here actually behaves this way. Small hydrothermal explosions on this scale aren't especially rare. Something on this order happens somewhere in the park roughly once a year. Larger events grow progressively rarer as their size increases. An explosion large enough to leave behind a sizable crater happens on the order of once every few centuries. The truly massive events, the ones that carve out craters larger than 10 acres, occur perhaps once every several thousand years. The largest hydrothermal explosion crater on the planet sits along the north edge of Yellowstone Lake, a feature called Mary Bay, roughly a mile and a half across, blasted out an estimated 13,800 years ago. Measured purely by raw size, this June's event sits comfortably at the small, relatively frequent end of a very long historical scale. What isn't routine, what genuinely earns this story its attention, is the combination of two specific things. It's the closest any hydrothermal explosion has ever occurred to dedicated scientific instruments in recorded history. And it's the clearest documented case of a new pool forming purely through days-long ground collapse, then beginning to erupt entirely on its own, all captured in detail, by cameras and sensors rather than pieced together afterward from debris. That is the actual first here, not the explosion. The record of the slow-motion failure that followed it. It's worth walking through why this mechanism is so difficult to spot coming, because that's really the crux of the entire warning researchers have been trying to communicate for years. Underneath Yellowstone's thermal basins, hot water constantly circulates through a maze of shallow cracks and channels running through the rock. That water carries dissolved silica picked up from the surrounding rock at depth. As it rises and gradually cools, the silica comes out of solution and precipitates onto the walls of these underground channels, slowly building up a hard, glassy mineral coating over time. That coating is essentially impermeable. As it thickens, it can seal off an entire pathway, capping a channel that had previously been venting heat and pressure safely to the surface. Once a conduit is sealed this way, the hot water and steam trapped beneath it have nowhere left to go. Pressure builds, temperature climbs. What you end up with is superheated water held under intense pressure, trapped beneath a layer of rock and mineral seal, essentially a natural pressure cooker sitting just a few feet beneath ground that people walk across every day. And it stays stable, looking completely ordinary from the surface, right up until the moment the confining rock simply can't hold anymore. When that seal finally fails, pressure drops instantly, the superheated water flashes explosively into steam, and that steam expands with enough force that the ground above either blows outward violently, or, as happened here, destabilizes and collapses inward instead over the following days. The scientist in charge of the observatory has pointed out something else worth remembering, which is that these basins can host all sorts of different plumbing arrangements sitting shoulder to shoulder without necessarily being connected to one another. When the 2024 explosion tore through Black Diamond Pool, nearby features in the same basin didn't visibly react. When this year's explosion opened new ground barely 100 feet north of that same pool, Black Diamond itself didn't appear to be significantly affected either. That's actually part of what makes forecasting so difficult. It isn't one large interconnected system where pressure changes ripple predictably from one feature to the next. It behaves more like a patchwork of individually sealed pockets, each one capable of failing entirely on its own terms, on its own schedule, with essentially no signal shared between neighboring features. A pool that has been calm and reliable for decades can sit a stone's throw from ground that suddenly tears open with no relationship between the two events at all. That patchwork nature is exactly why a single well-instrumented event like this one carries so much weight scientifically, even though the explosion itself barely qualifies as newsworthy by Yellowstone's own historical standards. Researchers can't simply extrapolate from one feature's behavior to predict another's. Each pocket of superheated ground is, in a sense, its own sealed experiment, and the only way to learn anything meaningful about the general warning signs, if any exist at all, is to have instruments running at the exact moment one of these pockets fails. That has happened, for all practical purposes, exactly once in the entire recorded history of this hazard, which is why the phrase unprecedented opportunity keeps showing up in the language scientists are using here, not as marketing, but as a fairly literal description of how rare this kind of close-range recording actually is. There's also a broader implication here that reaches well past the boundaries of the park itself. Hydrothermal and geothermal areas exist all over the world, many of them far more heavily visited or built up than anything in Yellowstone's backcountry. Geothermal fields power homes and businesses in places like Iceland, New Zealand, and parts of the western United States, and shallow steam. Driven explosions of this same general type have caused injuries and fatalities at sites well beyond this park over the decades. If researchers manage to extract even a partial precursor signal from this data set, something as simple as a subtle temperature drift or a particular pattern in low-frequency acoustic noise in the hours before failure, that knowledge doesn't stay contained to one basin in Wyoming. It becomes a template other observatories around the world could theoretically apply to their own monitoring networks. That's the stakes riding on a few weeks of a small research team poring over seismic traces and infrasound recordings from a blast that, on its own, barely dented the park's annual quota of minor hydrothermal events. So here's what to actually watch going forward. The observatory now holds a data set unlike anything it has had access to before, and researchers will spend the coming weeks, and likely months, poring over it, looking for any hint of a genuine precursor buried in those recordings. If they find one, expect a real, meaningful step forward in the ability to forecast these events before they happen, something that could eventually protect people at geothermal sites well beyond Yellowstone. If they don't, expect scientists to say so plainly, and expect Biscuit Basin to remain closed indefinitely, because the lesson in that case would be blunt. This particular ground can fail with no advance notice whatsoever, and there may be no way around that using current technology. Keep an eye on the new collapse pool as well. Whether it keeps spouting on its own, settles into something calmer, or continues to grow, will say a lot about whether this underground system is still actively reorganizing itself or finally beginning to stabilize. Several of the vents opened on June 13th have already dried up in the weeks since, and the basin has grown noticeably less active overall, though scientists are careful to note that quieting down and being finished are not the same thing. The supervolcano is not waking up. On that specific point, the data could not be clearer, and every scientist actually working this problem will tell you so without hesitation. But the ground inside Yellowstone's thermal basins has just demonstrated, in more detail than ever recorded before, exactly the scenario researchers have quietly warned about for years. That it can fail silently, tear open, collapse inward, and keep boiling over for days at a stretch, all without a single obvious sign beforehand. And the most realistic danger inside America's first national park was never buried miles underground at all. It's sitting quietly, right now just a few feet beneath the ground people are standing on.